Factors affecting rates of reactions. The speed of a reaction is called the rate of reaction. The speed of chemical reactions varies hugely. Some reactions are very fast, while others occur very slow. As in the example shown, the rate of reaction involved in the explosion of fireworks is faster compared to the rate of reaction involved in baking. Comparatively, the rate of reaction involved in the ripening of fruits like strawberries is slower and may take months as compared to baking, which is completed in minutes, and as compared to the ignition of fireworks, which immediately reacts in a matter of seconds. The speed of chemical reactions as observed during experiments in the laboratory also varies hugely. Some chemical tests, such as Benedict's test, requires heating the mixture for at least 3 minutes in order for a color change to be observed. Some reactions occur instantaneously without the application of heat, such as the reaction between magnesium ribbon and hydrochloric acid. The magnesium ribbon totally dissolves in the acid in about a minute. Some reactions occur very fast, in a matter of seconds, such as the explosive reaction of sodium in water. Chemical reactions take place when particles collide with a certain amount of energy. The minimum amount of energy needed for particles to react is called the activation energy. If particles collide with less energy than the activation energy, they will not react and just bounce off each other. Correct orientation of colliding molecules also contributes to successful collisions. The rate of reaction depends on two things: the frequency of the collisions and the energy with which particles collide. Anything that increases the number of successful collisions between reactant particles will speed up a reaction. The following factors may affect the rate of reaction: concentration, temperature, particle size or surface area, nature of reactants, and the presence of catalysts. The procedures for this experiment are based from Activity 4.2, Factors that affect the rate of reaction, found in pages 139 to 142 of your textbook, Breaking Through General Chemistry 2. Before testing the different factors that affect the rate of reaction, powdered chalk samples were prepared. One-gram samples of the powdered chalk were weighed using a digital balance. Effect of concentration on the rate of reaction. In this test, 3 solutions of hydrochloric acid of varying concentrations will be used. The concentration of the hydrochloric acid used are 0.5 molar, 1 molar, and 3 molar. 3 test tubes were labeled according to these concentrations. 1 gram of powdered chalk was added into each test tube. Two ml of each hydrochloric acid solution was prepared. A timer was also prepared. The hydrochloric acid solutions were simultaneously added to the test tubes and the timer was started. Record the time reaction started. Notice that as hydrochloric acid reacted with the calcium carbonate in the powdered chalk, bubbles of carbon dioxide gas are produced. When no more bubbles are produced, we can infer that the reaction has ended. Take note of the time reaction ended for each test tube. Effect of temperature on the rate of reaction. In this test, the test tubes containing the reactants, hydrochloric acid and powdered chalk, will be placed in beakers of varying temperatures. The first one will be placed in a hot water bath, the second in an ice water bath, while the third in room temperature water. 1 gram of powdered chalk was added into each test tube. Two ml of 3 molar hydrochloric acid solution was prepared. A timer was also prepared. The hydrochloric acid solutions were simultaneously added to the test tubes and the timer was started. Record the time reaction started. Notice that as hydrochloric acid reacted with the calcium carbonate in the powdered chalk, bubbles of carbon dioxide gas are produced. When no more bubbles are produced, we can infer that the reaction has ended. Take note of the time reaction ended for each test tube. Effect of particle size or surface area on the rate of reaction. In this test, powdered chalk and a piece of chalk will be used. Both the powdered chalk and the piece of chalk were weighed using a digital balance. Both chalk samples have a mass of 1 gram. The chalk samples were added to 2 separate test tubes. Two ml of 3 molar hydrochloric acid solution, which will be added to each test tube, was prepared. A timer was also prepared. The hydrochloric acid solutions were simultaneously added to the test tubes and the timer was started. Record the time reaction started. Just as observed in the previous procedures, the bubbles formed are carbon dioxide gas that were produced from the reaction of hydrochloric acid and calcium carbonate. The time reaction ended was based on the elapsed time wherein no more bubbles are produced. Take note of the time reaction ended for each test tube. Effect of the nature of the reactants. For this procedure, the reactivity of three metals when added to hydrochloric acid will be tested. The metals to be tested are magnesium, zinc, and copper. Magnesium ribbon was tested first. 2 ml of 3 molar hydrochloric acid was added to a test tube. A piece of magnesium ribbon was added to the acid and the timer was started. Record the time reaction started. It can be observed that bubbles were immediately produced upon the addition of magnesium ribbon to the hydrochloric acid. These bubbles are due to hydrogen gas produced from the reaction. The time reaction ended was based on the elapsed time wherein no more bubbles are produced. Record the time reaction ended for magnesium and hydrochloric acid. The reactivity of Moss's zinc was tested next. 2 ml of 3 molar hydrochloric acid was added to a test tube. A piece of Moss's zinc was added to the acid and the timer was started. Record the time reaction started. Just as observed in the previous procedures, the bubbles formed are hydrogen gas that were produced from the reaction of hydrochloric acid and Moss's zinc. The time reaction ended was based on the elapsed time wherein no more bubbles are produced or until 6 minutes has already passed. In the case of Moss's zinc, bubbles were still produced even after 6 minutes. Hence, the recorded time reaction ended is 6 minutes. The reactivity of copper wire was the third to be tested. 2 ml of 3 molar hydrochloric acid was added to a test tube. A piece of copper wire was added to the acid and the timer was started. Record the time reaction started. Unlike the first two metals, there were no bubbles of hydrogen gas that were produced when copper wire was added to hydrochloric acid. This indicates that no reaction has taken place. Effect of catalyst on the rate of reaction. In this procedure, the effect of adding catalyst to the rate of the composition of hydrogen peroxide will be tested. 4 graduated cylinders were labeled 1, 2, 3, and 4 respectively. 3 catalysts will be used, namely copper 2 oxide, manganese 4 oxide, and potassium iodide. 5 ml of hydrogen peroxide was added to each of the graduated cylinders. Two ml of dishwashing liquid was added to cylinders 2, 3, and 4. The initial volumes of the liquids in each graduated cylinder was measured and recorded. Approximately 0.3 grams of each of the catalysts were prepared. The 3 catalysts were simultaneously added to their respective graduated cylinders. When hydrogen peroxide decomposes, it is broken to water and oxygen gas. The formation of bubbles is an indication that a reaction is taking place. The rate of production of oxygen gas will be based on the layer of foam or bubbles produced in the graduated cylinder after about 2 minutes. The final volume of the liquid and foam in each cylinder was recorded. The volume of bubbles or foam produced in each cylinder was calculated by subtracting the final and the initial volumes. The greater the rate of production of oxygen gas, the greater is the catalyst's catalytic power. Graduated cylinders 2, 3, and 4 was compared to cylinder 1, which is the control setup, since it was not added with a catalyst. Here are some reminders in writing your journal report for this experiment. In the observation column of the analysis table of your journal report, present the data and observation for each factor in tabular form. Follow the tables in pages 141 to 142 of your textbook. An example is provided for you. For the guide questions, answer the questions for analysis in page 143 of your textbook. And that concludes our experiment on the factors affecting rates of reaction. We hope that through this video, you were able to understand how concentration, temperature, particle size, the nature of reactants, and the presence of catalysts affect the rate of reaction. Thank you for watching.